In this video, we will learn electric flux and Gauss's law. In order to understand Gauss's law, first we need to understand electric flux. The number of electric field lines passing through the area normal to the surface is called electric flux. To better understand, look at this diagram. This is the pattern of electric field lines due to a positive charge. Now suppose 2 points P and Q. Consider circular area of same size at point P and point Q. You can see that the number of electric field lines passing through the area is different at different points. You also know that the electric field intensity at point Q is more, therefore more electric field lines passing through the same area. Here electric field intensity is low, therefore less number of lines passing through the same area. It means that the number of electric field lines passing through the area depends on electric field intensity. Now suppose we increase the area. Now more number of electric field lines passing through the area. It means that the number of electric field lines passing through the area, that is flux, also depends on the magnitude of area. And now suppose the area is slightly tilted. Suppose this is a circular area placed at point P like this. Now tilt this along this direction. Suppose we place it like this, then no electric field lines passing through this circular loop. It means that the number of electric field lines passing through the area depends on orientation. Then how to specify the orientation? For this, area can be treated as a vector quantity. If area is treated as a vector, it is called area vector. The magnitude of area vector is equal to its area and its direction is perpendicular to the surface, and for the closed surface its direction is outward normal. Suppose a very small area ds, the area vector that is along this direction, this is denoted as very small area element, so ds vector. Direction of area element is always perpendicular to the surface, outward normal direction. Suppose electric field at this point is in this direction. This is the angle between electric field and area vector. Suppose this is theta. The orientation is given by this angle. You know that the component of area vector along electric field vector is ds cos theta. So electric flux through the small area d phi is given by E ds cos theta. that is the number of electric field lines passing through the area, that is electric flux, depends on electric field intensity, its area and orientation of the area. It can also be written as d phi is equal to E vector dot ds vector. The electric flux is defined as the dot product of electric field and area vector. Since it is dot product, so it is a scalar quantity and its SI unit is Newton meter square per coulomb. The total electric flux can be calculated by integrating it. That is, total electric flux phi is equal to integral d phi, which is integral E dot ds, and it is also equal to integral E ds cos theta. To get the better understanding of what electric flux is, bring three rectangles in this electric field in different orientation. In first case, area vector is along the direction of electric field. Here theta is equal to 0 and cos 0 is equal to 1. Therefore, electric flux is equal to EdA. In second case, the area vector makes an angle 60 degree with the electric field. Here theta is equal to 60 degree and therefore d phi is equal to EdA by 2. In third case, area vector makes 90 degree to the electric field. Cos 90 is equal to 0 and therefore electric flux is equal to 0. To learn how to calculate electric flux, let us take an example. Suppose a cylinder of cross-section area A is placed in uniform electric field such that its axis is along the direction of uniform electric field, like this. This area is A and electric field is E. Suppose we have to calculate electric flux through this cylinder. This is a closed surface. The cylinder is closed by here a circular area and here another circular area. So it is a closed surface. Now we know that cylinder has three surfaces. One is circular area. Suppose this is surface 1. This circular area is suppose surface 2 and curved surface area surface 3. Since electric flux is a scalar quantity, so we calculate electric flux through each surfaces. For first surface, consider a very small area ds. The direction of area vector is outward normal, that is along electric field direction. The angle between area vector and electric field is 0. So flux through the surface 1, that is phi 1 is equal to integral E dot ds or E ds cos theta. Integral E ds cos theta. Here theta is 0 and cos 0 is equal to 1. Therefore, it is equal to integral E ds. Electric field is uniform, that is constant. So electric field comes out from the integration and it is equal to integral ds. Integral ds is equal to the surface area, and surface area is A. Therefore, it is equal to E into A. If the surface is a plane surface and placed in uniform electric field, you can directly use formula phi is equal to E vector dot A vector, total area. Now for surface 2, flux through the surface 2, phi 2 is given by, since it is a plane surface and placed in uniform electric field, so we can directly use this formula. Phi is equal to E dot A vector, which is equal to E A cos theta. Here area vector is along this direction, this is A vector, and direction of electric field is along this direction. Here angle theta is equal to 180 and cos theta, cos 180 is equal to -1. Therefore phi 2 is equal to minus EA. Now the flux through the curved surface area. Here suppose a very small area element ds, direction of area element is always outward normal direction. This is the direction of area vector, and electric field lines is along this direction. The angle between area vector and electric field is 90 degree. So for curved surface, that is phi 3 is equal to integral E dot ds or integral E ds cos theta. Here theta is 90 degree and cos 90 is equal to 0. Therefore flux is equal to 0. The total flux is the sum of all these fluxes. So total flux phi is equal to phi 1 plus phi 2 plus phi 3. Putting the values, we get plus EA minus EA plus 0, which is equal to 0. So total flux through the cylinder placed in uniform electric field is equal to 0.